You are welcome to this section. In today's topic, we are going to be studying separation processes. We all know that what separation processes, or we say separation techniques, they are the process or methods that are used to separate components of mixtures. As we've learned in our previous lessons that mixtures can be separated by physical methods. The physical methods are called separation processes, or you call them separation techniques. Now, the first one we are going to be studying today is the filtration. Now, the apparatus you need to get ready whenever you want to carry out filtration is the funnel and majorly the beaker. And you see this part here in blue, the filter paper. You need the funnel, the filter paper, and you need the what? And you need the beaker. You see this stand is for you to hold the what? The funnel. You can do it locally by using your hand to hold it, but if I want to make use of my lab apparatus, I'll make use of what? Retort stand. This one you see here is called what? Retort stand. This is it here, retort stand. Good. So how do we carry out this separation, this filtration? You see, filtration is used. Look at the wordings here. Filtration is used to separate insoluble solid from a liquid. The word insoluble means something that do not dissolve. So if I say I have insoluble solid in a liquid, it means that what? The solid cannot dissolve in the liquid. The opposite is soluble, which means it can dissolve. If I put salt in water, the salt will dissolve totally. That looking at it, you won't know that what there was salt there. It means that what that salt is soluble in water, it means that it can dissolve in water. If I put charcoal in water, charcoal is not soluble. You'll be seeing it this way, like it will not dissolve. That is the meaning. So insoluble means it will not dissolve, while soluble means it will dissolve. Now, this method is used to separate insoluble solid from a liquid. Now, example, if I want to separate salt solution from sand, how do I do it? You see, I have water that salt has been dissolved in it to form a solution, then sand is now inside. So how can I separate that salt solution? In other words, how can I separate salt water from the sand? I'll set up this apparatus and I'll put my filter paper here. Now, I'll stir the mixture and pour it inside this funnel. And what happens? Now, pay attention that salt solution and sand have two components. The salt solution is the soluble component, and the sand part is the what? Is the insoluble component. Like I said, the sand will not dissolve. Sand cannot dissolve in water. So sand is the what? Is the insoluble component. Now, when you pour the mixture into this funnel, the insoluble component will be trapped at the filter paper. So the insoluble component is called the residue. The part that is insoluble will be trapped at the filter paper. And remember, sand will be trapped at the filter paper. It means that the sand is the residue. Exactly. Now, the salt solution is the soluble component. The soluble component will pass through the filter paper into this beaker you have here. And that component here is the salt solution, which is the filtrate. It means that after you separate using filtration, you will have the residue and you also have the filtrate. The residue is the insoluble component, while the filtrate is the soluble component of the mixture. Now pay attention. If they ask you that, on what principle does filtration operate? Or on what principle is filtration based on? You see, filtration is based on principle of insolubility. What do I call it? Insolubility. Let me tell you something. All separation techniques work on a particular principle. And if you can observe that principle, you will know a particular separation technique to employ. Now, what does this principle of insolubility mean? It means that I observe that something is insoluble in this solution. What will I use? I'll just use what? Filtration. And that is it. So the sand is what? Is insoluble in this what? In this salt solution. Therefore, I will not carry out what? Filtration. Now, is filtration possible for you to separate salt from the water? No. Because if you look at salt water, salt is what? Is soluble. Everything will just go into the filter paper. So this method is not suitable to separate salt from water. Now, the next separation process is decantation. Now, decantation is used to separate insoluble solid from a liquid. It actually have the same function as filtration, just the same function, but they are just slight difference. Number one, if you look at filtration, we make use of filter paper, but in decantation, nothing like filter paper here. So take note of that. Now, what do we now do under decantation? Well, firstly, you see this beaker that has, this is a liquid and this brown part is a solid. Are you there? That is, there is a particular solid that has settled down. So you place it to settle down. Then what happens? You now start pouring this water gently and let it pour here. So when you just see that, oh, this water has fully, like it has fully left this side to this side, then you have carried out what? Decantation. Let me tell you a short story. Here in Nigeria, when people take garri, the one you call cassava flakes, now when you put that in water and you want to sieve out those dirty part out of it, what will you do? You put water in the garri and just pour the water out. That thing you are doing is what we call decantation exactly. So the water you have here is the decanted water. Are you there? Good. So it also carry out the same function as filtration. It is used to separate what? Insoluble solid from a liquid. Simple. Now, remember, look at the principle of this method. This method is based on the insolubility of a solid in a liquid. Yeah, that is the principle. That is, we observe that it is used to separate insoluble solid from a liquid. So therefore, the principle is what? The principle is based on insolubility of solid in a liquid. That is, you can use it whenever you are having insoluble solid in a liquid. You can never use it when you are having soluble solid in a liquid. Let me give you an example. Put salt inside water and mix it together. Remember that what salt is soluble, it will dissolve. So can you use this method to separate salt? It will never happen. Just try it. So because it did not even obey the principle of decantation and filtration, they have the same principle. The principle is that what? It is based on insolubility of a solid in a liquid. You can use it to separate insoluble solid from a liquid. That's all. And at times, you can see them putting something like a glass rod around this side there. You see them putting like a glass rod around this side. Yeah. Do you know that it is possible that some of this brown particle might want to fall off? So this glass rod will just block it from falling off, and that is that for that. So this is called a glass rod. So that's that for that. So thanks for watching. Now you are welcome to this section. We are going to be studying evaporation to dryness in this video. Now this method is used to recover soluble solid from a solution. Check something out. Soluble solid from a solution. Now remember, the meaning of the word soluble means that what? This solid can actually dissolve. That's why we call it soluble. Now take note of something about solution. When we say solution, have this thing in mind, consists of what we call solute and what? And solvent. All together? Good. So if I have salt water now, for example, the salt is the solute and the water that is dissolving the salt is the solvent. So this is the salt and this is the what? This is the water. So the water is the what? Solvent. Don't forget, the water is the what? Solvent. Now, take note that for you to use this method effectively, the solid must have high melting point. Look at it. For example, now, the melting point of sodium chloride is 801 degrees Celsius. Yes, that is very important. Why? Because if this solid don't have high melting point, it will easily decompose on heating, and you will not even be able to carry out this separation to decompose on heating. Everything will just disappear with the water and everything. Take note of that. Now, on what principle does this evaporation to dryness operate? On what principle? You see, the principle is based on the large difference between the melting point of the solid and the boiling point of the solvent. I will explain something. Salt has a melting point of 801 degrees Celsius and water is 100 degrees Celsius. You can see the large difference. Remember, if I'm trying to heat this thing up, the heat from this boiling water will heat up this evaporating dish, and what happens? The water will evaporate as gas away. Then your salt can be left behind. Now remember, what should leave first? What we expected this to, we expect the water to leave first so that the salt will be left behind, right? Good. Now let me now say that the melting point and the boiling point of this liquid are now close. Let me assume that the melting point of the solid that we are dealing with is about, let me say, 98 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Now see, it means that if you are eating this substance, let me say I have a thermometer here now. If you are eating this substance When the temperature get to 98 degrees Celsius, what happen? The solid will decompose. That is, even before the water will evaporate, the solid has already decomposed. Are you there? That is, there must be large difference. Also, the melting point of this solute must be higher than the boiling point of the water. So that the reason for this is that what? So that water will leave first. Look at 100 degrees Celsius. Remember, if you count 1 to 3, 100 will reach before 801 exactly. That is, this that is, there must be large difference between these two numbers so that the water can leave first and the salt will be left behind. That's all. Okay, so that's that for that. We are going to be studying crystallization, fractional crystallization, and recrystallization in this video. So everything about crystallization. Now let's go. This method is used to obtain crystals of soluble solid from a saturated solution. Keep this aside. Crystallization and evaporation to dryness perform the same function, but this is the basic difference between them. Evaporation to dryness, that one, the solid must have high melting point. But crystallization, the solid, it is used for solid that has what? Low melting point. For example, sugar. Sugar can easily decompose. Remember, it is a covalent substance and the melting point is very low. So we use crystallization for that. And also, when the purity of the substance is really considered, we use crystallization. That is, crystallization produce purer solids than evaporation to dryness. I've given us two different between them. This one, low melting point solid, and also it produces purer solids than evaporation to dryness. Now, so we apply it in drug industry and what, and sugar industry. Now, how do we even carry out crystallization? Pay attention. You see, when we have soluble solid in a solution, what do? We heat the solution so as to evaporate some of the solvent, part of the solvent. Are we there? Then to obtain what we call a saturated solution. That is a solution that contains solutes that it can dissolve. For example, the solute and the solvent are balanced. Are you there? Good. That's a saturated solution. Then after heating them, you obtain a saturated solution and you allow the saturated solution to cool down. You allow the saturated solution to cool down, and when it cools down, what happens? The crystals of the solid will appear. These are practicals that can be done in the lab. The crystals of the solid will appear on cooling. That is, you try to cool it down, then the crystals will appear. So when the crystal appear, then you can obtain the crystal, and you have carried out what? Crystallization. Now, if I obtain the crystal and start repeating the process, add another fresh solvent, heat the solvent, obtain a saturated solution, cool again to obtain crystal. That is redoing what you have been doing again and changing the water using fresh solvent. That's what we call recrystallization. This is done to obtain solids that are more pure again. Are we following? So crystallization that is done repeatedly is called recrystallization, and that's all. So let us look at fractional crystallization. You see, this one is used when you want to obtain two or more soluble solids. All together, let me say I have two or more soluble solids. Now we'll use what? Fractional crystallization. Now the key point says that what? If they ask you which of the solid will crystallize out first, it is the one that it is the least soluble solid that crystallize out. That is the one with lowest solubility crystallize out first. So that's that for that. Yeah, welcome to this section. Our next separation process is centrifugation. Now, what is centrifugation? Centrifugation is used to separate fine solids from a colloidal solution. Now, what do we call colloidal solution? And what's the meaning of fine solid? You see, fine solid does not mean something is handsome or beautiful. It means that the solid is very, very small. When you hear fine solid, it means that the solid particle is very, very small. Like really, really small. That's the meaning. And what's the meaning of a colloidal solution? You see, when you get to solution and solubility, you get the full detail of colloidal solution. But in a layman language, what's the meaning of colloidal solution? Pay attention. In a colloidal solution, the solid particles cannot settle down on standing. Remember that if I have solids in liquid and you put it for some time, it will settle down on standing. It will settle. Then you see that, oh, solid have settled down. But in colloidal solution, they can never settle. Why? Because the solid particles are too minute, they are too small. Example of colloidal solution is milk. Try to put Dano milk in water and try to see if Dano milk will settle down. No. That is, the particles of Dano milk is too small. So it's an example of colloidal solution, okay? Milk. Also your blood. Remember that what the solid component of the blood is called the blood cells. The blood cells are too minute in a way that what they cannot settle down on standing. Blood is also an example of what a colloidal solution. Are we together? Take note of that. Now, a colloidal solution cannot be filtered because the solid particles are too small. Yes, that's what I said. That was the solid particles there. Okay, try to put dynamic in water, set up your filtration apparatus and pour it inside the funnel. You will see that filter paper can never trap particles of dynamic because they are too small. So all of them will just fall inside what? All of them will just enter inside the what? The filter paper because they are too small. So you can never filter a colloidal solution. It is not possible. Why? Because of the smaller nature of the particles. Now, what do we use centrifugation for? It's mostly used in hospitals to separate blood cells from plasma. It's used in the hospitals and laboratories to separate blood cells from plasma. Remember, the blood cell are the solid component of the blood, while the plasma is the liquid component of the blood. So a way to separate them is using what we call what? Centrifuge. It's like a round machine like this with test tubes all around it. Are you there? Good. So that's that for that. Thanks for watching this section. Yeah, welcome to this section. Here we want to study the simple distillation. We want to look at the simple distillation. So let's go. What simple distillation used for? Well, the first one is that it's used to obtain pure solvent from a solution. Have this keyword in your mind. To obtain pure solvent from a solution. For example, if they tell you that, how can you obtain pure water from seawater? We use simple distillation. Now, how do we go about it? Now, look at this apparatus. Now, excuse me. You can see your heater stand. This is a round bottom flask. Your condenser. This is a conical flask. Good. So let's see. Let me say I have impure water here. Let me say the impure water represents seawater, for example. Now, what happened? We eat this mixture. Number one thing that we eat. After eating the mixture, remember that it will get to a point whereby, see the thermometer, water will get to what? 100 degrees Celsius. And remember, when water gets to 100 degrees Celsius, it has gotten to the boiling point. Therefore, it will leave in form of what? In form of steam. Are you there? Then, when the steam gets to this condenser, what happens? Now, let me remind you of something. What's the meaning of the word condensation? Condensation means that what? When gas turns back to liquid, that is condensation. Gas turning back to what? Liquid. So when the gas is that lives in form of steam here, when it gets here, what happens? It is being cooled by the condenser. And if you cool gases, they will come back to liquid. Are you there? So when the gases come here, they become cooled as liquid, and the liquid will come here this way. And that's it. So when the water gets to 100 degrees Celsius, till everything leave, everything will come here as distilled water. You see, this type of separation technique is to, like, this distilled water is the purest form of water that you can obtain. Altogether, so that is it. So when you eat, this separation technique is based on difference in boiling point. Difference in what? In boiling point. Are you there? Remember, water here we have smaller boiling point compared to the solid particles that can be there. Are you there? So when it gets 100 degrees Celsius, it comes here as gas and turn back to liquid. That's all. That's condensation. So that's that. So gas leaving, turning back to liquid in the condenser, coming back as liquid again. You can see liquid, gas, liquid, and so on like that. So that's the first function of distillation. The second function of distillation is that it is used to separate liquids of wide difference in boiling point. For example, if I mix ethanol and water together, they are completely miscible. Ethanol has boiling point of 78 degrees Celsius, water 100 degrees Celsius. The boiling point is very large. So if you have a large difference in boiling point, remember the principle of distillation is what? Is large difference in boiling point. Large what? Large difference in boiling point. That's the principle of distillation. So if you see that what? The boiling point is what? Is very large. Yes, 78 to 100 is very large. So when you put both of them in this round bottom flask, what happens? When you eat, which one will leave first? You have ethanol 78 degrees Celsius, you have water 100 degrees Celsius. Look at the thermometer. Which one will it get to first? It will get to 78 degrees Celsius, and what? Ethanol will leave. Are you there? And come here and what? And it's being distilled here. Are you there? So ethanol will leave, and it will be the one that, you see, the liquid you see here is called the distillate. So if they ask you that in the separation of ethanol and water, which one will be the distillate? Is the one with lowest boiling point, because it is the one that will leave first. So that is it. And this distillation is used in production of what, distilled water on a large scale. Also, it is used in production of what, alcoholic beverages like brewery and so on like that. So that's that for that. Thanks for watching.